Okay, fine. So, uh, in the last class, we have discussing about this time domain specifications, where we have discussed about the rise time, delay time, rise time, peak time, and peak overshoot, and we have also seen the expressions for this rise time, peak time, peak overshoot, settling time, and also we have seen some of the problems regarding this particular concept, right? We have practiced some of the problems in the last class, particularly based on this whatever that concept we have discussed, right? So we'll just now move to the another new topic, particularly what we're having. So enough problems we have discussed in the previous class, so that is much that is sufficient for us, and you're supposed to practice more number of problems, right? So now when we moving to this some another new topic, here we supposed to discuss about the one second, yeah. Now we supposed to discuss about this time number of control systems. What do you mean by the time number? What do you mean by the sorry, what do you mean by this type number of a control system? What is the type number? So the type number is specified for the open loop system. Is it clear? Open loop transfer function g of s h of s. So the number of poles of the loop transfer function lying at the origin decides the type of the system. Is it clear? The number of poles uh, of the loop transfer function lying at the origin which decides the type number of a system. For example, if n number of poles at the origin, then the type number is n. If we are having a n number of poles at the origin, what will be the type number? The type number is n. Now here suppose I am having a transfer function which is expressed as a ratio of two polynomials. Is it clear? Having a loop transfer function which can be expressed as a ratio of two polynomials in S domain, g of s is, and h of s. Here, see here clearly, when g of one second, one second, yeah. Here we are having g of s and h of s equals to k into p of s by q of s, numerator polynomial by denominator polynomial. In a factorized form I am writing in such a way that k into s plus z1 into s plus z2 into s plus z3 so and so by s power n into s plus p1 plus s plus p1 into s plus p2 into s plus p3, right? So here this z1 z2 z3 are nothing but zeros of the transfer function, and whereas poles of and p1 p2 p3 are nothing but poles of the transfer function. And here in this equation this k is constant and n is number of and what about this n is number of poles at the origin. So what I did here, I have taken the nth order differential equation. For the nth order differential equation I have written in the factorized form, and now after writing that in the factorized form, whatever this z1 z2 z3 z1 z2 z3 are nothing but the zeros, p1 p2 p3 are nothing but the poles, and where k is nothing but constant. And what about this s power n? This n is nothing but what? Number of poles at the origin. So the value of n in the denominator polynomial of a loop transfer function uh, decides the type number of a system. If n equals to 0 means that is type is zero system, zero type system, type number is zero system, right? And if n equals to 1 is type 1 system, n equals to is type 2 system, n equals to 3 means type 3 system, and so on it will be continued. Is it clear? I hope that everyone got a clear idea about the type number of a system. And also uh, one second, some of the student asking me to hello. Is it clear? Fine. So now we're going to discuss about the another topic, that is the steady state error. So what do you mean by the steady state error? So how, what do you mean, what why we are supposed to discuss this steady state error? So the steady state error is nothing but it is the value of a error signal e of t when t tends to infinity. It is nothing but what, it is the value of error signal e of t when t tends to infinity. The steady state error is nothing but simply it is a measure of system accuracy. It is nothing but what we can say simply in simple terms, it is a measure of system accuracy. Particularly these errors arise from nature of inputs. Particularly now, we are seeing different types of errors. How come these errors will appear? So what is the reason? So particularly the rise of these errors are from nature of the inputs, type of the system, and from non-linearity of the system components. Like that, due to these reasons we facing such kind of errors. Particularly what are the reasons? Due to the nature of the systems, that might be one reason, due to type of a system, and due to non-linearity of the system components. So we are raising some sort of errors. So the steady state performance of a stable control system generally judged by what? By its steady state error. Is it clear? What is the main motto, main need of this steady state error is what? To find out the steady state performance of a stable control system. Is it clear? For step, ramp, and parabolic inputs. For what? For different inputs, for the step input, for the ramp input, and for the parabolic inputs. For example, now what I'm doing here, I'm just considering one closed loop system. Here on the screen it is clearly visible to all. So here I have taken one closed loop transfer functions, closed loop system I have taken. So this is a closed loop system. uh, this is a closed loop system what we're having over here on the screen, right? So now, one second, one second. One second. Yeah, this is the closed loop system I have taken. Now for this closed loop system, what I having, RFS is nothing but the input. RFS is nothing but the input signal. Is it clear? RFS is nothing but the input signal over here. What we're having, EFS is nothing but error signal. Is it clear? EFS is nothing but error signal. One second, some of the students messaging me. One second, I will come back to you. I So EFS is nothing but error signal. Now here, what is the feedback signal over here? Whatever feedback signal here is nothing but C of S into H of S. Whatever here we are having is the feedback signal, right? And what is the C of S? C of S is nothing but the output signal, or we calling it as a response. Is it clear? Now, how you generating the error signal? What is this error signal? What is this E of S? E of S is nothing but what? E of S is nothing but R of S minus, is it clear? R of S minus C of S into H of S. Is it clear? E of S, what is nothing, E of S is nothing but our error signal. Is it nothing? It is nothing but what? R of S minus C of S into H of S. Now we know that this output signal C of S is nothing but what? E of S into G of S. It is clear. It is clear for all. Sir, చెప్పండి సార్. అవును సార్, మేడంకి నేను అడిగాను, కానీ మేడం ఏమీ ఇవ్వలేరు నాకు, రిప్లై ఇవ్వలేరు క్లాస్ గురించి. మేడంకి అయితే నేను నిన్న మెసేజ్ పెట్టాను, అది చూసారు మేడం, కానీ ఎప్పుడు రిప్లై ఇచ్చేటోళ్ళు, ఓకే వివేక్ క్లాస్ షెడ్యూల్ చేయని, కానీ నిన్న ఏమి ఇవ్వలేరు. సో అందుకొరకు నేను ఇంకా ఏమీ షెడ్యూల్ చేయలేను. ఓకే. ఆ, ఓకేనా సార్? ఆ, నేను అడిగాను సార్, మెసేజ్ పెట్టాను మేడంకి, ఎప్పుడు నేను వాట్సాప్లో మెసేజ్ పెడుతుంటే మేడం రిప్లై ఇస్తుంటుంది, కానీ ఇవ్వలే నిన్న. ఓకేనా సార్? ఓకే సార్, రైట్ సార్. యా, సారీ ఫర్ ద డిస్టర్బెన్స్. Okay, fine. So now we know that the output signal is nothing but what, from this it is clearly seen that C of s is nothing but what, E of s into uh, E of s into G of s. It's clear. Now what I'm doing here, on substituting for C of s from the equation whatever here we are having, so here what we can write here, so we know that we know that E of s equals to what, E of s equals to R of s minus C of s into H of s. Now we know that C of s is what we are having, E of s into G of s. Just I'm substituting there for C of s. So this is the equation what we are having. Now finally from that equation what I'm doing is I'm just bringing out what is E of s. So finally E of s is nothing but what we are having here. I hope that it is clear for all. A simple mathematical analysis here we carrying out. So finally here what we are having is uh, E of s equals to R of s by 1 plus G of s into H of s. This we got. Now what we require? We require to know this E of t. That is right. Error signal in time domain. This is error signal. Whatever we got is in S domain. The thing is that we are dealing with this time. We are dealing with this time domain analysis, time response analysis. So we require error signal in we require error signal in time domain, right? We require error signal in time domain. So E of s equals to R of s by E of s equals to R of s by R of s by 1 plus G of s into H of s. Is it clear? That is in S domain. Now in time domain what we are having, E of t will be inverse Laplace transform of E of s. Is it clear? Inverse Laplace of transform of E of s, such that uh, now let steady state error will be what, the steady state error is defined as what, as the value of E of t when t tends to infinity. Already this we have discussed it. So uh, we got from this by taking the inverse Laplace transform of E of s, we got E of t. Is it clear? Now what we require to find out, we require to find out ESS. We require to find out ESS, that is the steady state error. Already given the proper idea what do you mean by this steady state error. It is defined as the value of E of t when t tends to infinity. E of t when t tends to infinity. It's clear. So now ESS is nothing but limit t tends to infinity E of t. Limit t tends to infinity E of t. Is it clear? Limit t tends to infinity E of t is nothing but our steady state error. One second. Here some fine. So this is the thing what we are having. Now here I am taking the final value theorem of Laplace transform that states that if f of s equals to Laplace transform of f of t, if f of s equals to Laplace transform of f of t, then limit t tends to infinity f of t equals to limit s tends to 0 s into f of s. This is the final value theorem what we are having. So it states that what, if f of s equals to Laplace transform of f of t, then limit t tends to infinity f of t equals to limit s tends to 0 s into f of s. Now using this final value theorem, what will be the steady state error here we will get? ESS will be what? ESS will be limit t tends to infinity E of t. That will be nothing but what? Limit s tends to 0 s into E of s. So finally what will be ESS? ESS will be what? This is the equation what we'll have. This is the equation what we are having. So limit s tends to 0 s into R of s by 1 plus GSHS. Is it clear? What will be ESS here? What will be ESS? So one second, ESS will be what? Just everyone is supposed to remember this formula. ESS will be limit s tends to 0 s into r of s by 1 plus g of s into h of s. I hope that it is clear for everyone. So this is the steady state error what we are having. You are supposed to remember this formula, it is very important. Is it clear? Now we'll look at some problems on the steady state error. Later we'll look at some problems. We'll now discuss about the static error constants. So what do you mean by the static error constants? So now here, when just take a control system when it is excited with the standard input. So I'm just taking one control system. Now what I'm doing is I'm just exciting that control system with the standard input signal. Is it clear? So the steady state error may be 0, may be constant, or may be infinity. So particularly whatever the value of steady state error, it depends on what? It depends on type number and the input signal. Already just now I have discussed it in the starting of this steady state error, right? So what I'm doing is I'm just exciting one particular control system, either any control system, either either particular any control system, electrical or whatever, electrical, electronic, and pneumatic, any control system I have taken. I have excited with some standard input signal. So whatever the steady state error, it might be 0, it might be constant or infinity. So the value of the steady state error depends on what? Depends on type number and the input signal. So particularly when we talk about the type 0 system, will have a constant steady state error when input is step signal. When we talk about the type 1 system, will have a constant steady state error when the input is ramp or velocity signal. When we talk about this type 2 system, will have a constant steady state error when the input is parabolic or acceleration signal. So for the three cases mentioned, the steady state error, whatever the three cases what we have discussed so far, the steady state error is associated with one of the constants. Is it clear? Now that constants will going to define now. That is that we calling it as a steady state error constants that we are going to discuss now. One is the positional error constant, one is the velocity error constant, another one is the acceleration error constant. So these are the three constants which we are going to discuss now. So what do you mean by this positional error constant? That is nothing but Kp equals to limit s tends to 0 g of s into h of s. And when we talk about this velocity error constant, Kv equals to limit s tends to 0 s into g of s into h of s. And acceleration error constant, Ka equals to limit s tends to 0 s square g of s into h of s. So this Kp, Kv, Ka are in general called static error constants. Fine. Now we are going to discuss about the steady state error when the input is unit step signal. Just to go through once, just everyone please go through this uh, steady state error and this steady state error once. Hello, hello, Amma. Yeah. No, no, I'm not getting any request from your side. I'm just seeing here, but I'm not getting any request from your side. If I get any request means, I will just accept that. No, here. No, 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 I'm not. Okay, ma, but I'm not getting any request here. If I get request means, I will just join in the meeting, but I'm not getting here. Yeah. Yeah, try it once. Why? Because for me no any request getting. Fine, just try it once. And just everyone please look at this this static error constants once. Is it clear? Now, steady state error when the input is unit step input. Now we'll discuss about the steady state error. Uh, one second. Some have give some test. Now my screen is visible. Is the screen is visible to everyone? Yeah, I'm sharing the screen. My screen is visible to all. Please respond, any one of you. Yeah, fine. Some of the students have sent me that your screen is not visible. So for that I'm asking you. Okay, fine. Yeah. So now we'll discuss about the steady state error when the input is unit step input. Now we everyone having a clear idea about what you mean by the steady state error, and what is the formula we supposed to take for this steady state error. That is nothing but ESS equals to what? ESS equals to limit s tends to 0 s into r of s by 1 plus g of s into h of s. Is it clear? Now here clearly given for us, we know that we are analyzing for the unit step input. Is it clear? The steady state error when the input is unit step input I am taking. So when the input is unit step input, what is r of s? It is 1. R of s is nothing but 1 by s. Now what I'm doing is I'm just whatever the r of s is not here we are having, I'm just replacing this r of s with 1 by s. So ESS is nothing but what? Limit s tends to 0 s into 1 by s by 1 plus gs hs. Now finally what we are having here, the final expression for this now 1 by 1 by 1 plus kp, right? Is that clear? 1 by 1 plus kp here we are having. Now what is this kp? Kp is nothing but already I said that positional positional error constant, right? Where kp is nothing but what? Positional error constant, and it is limit s tends to 0 gs into hs. Is it clear? So where kp is nothing but what? Positional error constant, it is given by limit s tends to 0 g of s into h of s. So the constant kp is nothing. Okay, positional error constant. Now what I'm doing, I'm working on this type 0 system. So I'm doing the analysis for the type 0 system. So if I have taken the type 0 system, kp equals to limit s tends to 0 g of s into h of s. So type 0 system what? S power 0, it will be 1. So is it clear? S power n where n equals to 0. Is it clear for type 0 system? So what happens, this is the equation what we are having. So finally uh, here in this case s equals to what? Yeah. So this is the final equation what we are having. uh, z1 into z2 into z3 so and so by p1 into p2 into p3 So answer that is nothing but constant. So what would be having steady state error 1 by 1 plus kp equals to constant. So hence in the type 0 systems, when the input is unit step, there will be a constant steady state error. Is it clear? Just look at this once. Everyone please go through once. I am giving 1 minute time. Please everyone go through this. If is it okay, or I want to repeat you, I supposed to repeat once again. If it is okay means I will move to the next topic, or else I will repeat once again. Is it okay for all? Shall I move to the next topic, or else I will I want I have to repeat once again. Please any one of you respond to me. So okay, fine, I'm moving to this next. So now I am taking this type 1 system. So for the type 1 system, here we are having s power 1. Is it clear? N equals to 1. So this is the equation what we are having. So place s equals to 0 over here. So finally what I am getting here, whatever this will be infinity, right? So ess will be what, 1 by 1 plus infinity, where kp is infinity here. So ess equals to 1 by 1 plus infinity, that will be 0. So what we can say here, what is the observation we can say, see here, in the system with the type number 1 and above, for unit step input the value of kp is infinity, and so the steady state error will be 0. Is it clear with this? This is for a unit step input. Just please look at this once from here to here, everyone. If not, please ask me or text me. I will explain you once again I will explain. Any doubts you having, or regarding this, please text me. Hello, చెప్పండి. చెప్పండి మేడం. చేస్తాను. మనకు 1 మంత్ గ్రేస్ పీరియడ్ ఉంది కదా, జనవరి అంతా. అంటే అర్థం కాలేదు. సరే, పే చేస్తాను. అయితే మాకు బెనిఫిట్స్ ఉంటున్నాయి అట్లయితే తొందరగా పే చేస్తే. సరే మేడం, పే చేస్తాను. 27th వరకు పే చేస్తాను. ఉంది కదా ఇంకా టైం, 27th వరకు. ఓకేనా? Is it clear? Everyone, it is clear? So now steady state error when the input is unit ramp. Till now we have discussed steady state error for the step input, unit step input. Now we are going to discuss steady state error for the unit ramp signal. So this is a formula for the steady state error, and when the input is unit ramp, RFS is nothing but what, 1 by s square. Basically just substitute this 1 by x square for R of s over here. So finally ESS will be 1 by kV. So ESS will be 1 by kV. And what about this kV? kV is nothing but what? kV is limit s tends to 0 s into g of s h of s. Is it clear? Yeah, kV is nothing but limit s tends to 0 s into g of s into h of s. This kV is nothing but what? Velocity error constant. Now first of all we will discuss about this type 0 system. For type 0 system we will discuss now. What is this g of s into h of s? This is the nth order differential equation in a factorized form I have taken. So limit s tends to 0, just replace s tends to 0 here. This is the type 0 system, right? Type 0 system. For this type 0 system, just place s tends to 0, so it will be 0 whatever the kV equals to 0. So ESS will be what? 1 by kV, 1 by 0, it will be infinity. Hence in a type 0 systems, when the input is unit ramp, the steady state error is infinity. Whereas in this case, when unit step signal, what will be in the type 0 system? It will be input will constant steady state error here we are having, but here it will be infinity in this case, right? It will be steady state error will be zero infinity. Now when we look at this type 1 system, type 1 system means here s power 1 we supposed to take. Is it clear? In the previous case s power 0 we have taken, here s power 1 we supposed to take. Just place s equal to 0 here. So finally this is the thing what we are having, k v equals to constant will have. So ess will be what, 1 by kv, that is nothing but constant. So hence in the type 1 systems, when the input is unit ramp, there will be a constant steady state error. Fine. Now if I go for the type 2 system, what happens? A square I supposed to take here, and this will be infinity. Fine, this will be infinity here we are having, and ess will be 1 by kv, that will be 0. So what we can say here, what is the observation, what is the result we can give here, conclusion you can give here. In a systems with type number 2 and above, for a unit ramp input, the value of kv is infinity, so the steady state error is here is 0. Is it clear? So that is for a type 2 system for a ramp signal, unit ramp signal. Similarly, what happens if it is input is a unit parabolic signal? Steady state. Now find the steady state error when the input is unit parabolic signal. Just go through once by your own. We'll discuss now. Make it fast. You people by your own go through once. Is it clear? So here this is a steady state error what we are having. What the input is a unit parabola, that is 1 by s square s cube. So just substitute for r of s over here. So finally ess will be what? Ess will be 1 by ka, where ka is nothing but what? Positional error acceleration error constant or parabolic error constant, that is limit s tends to 0 s square into gshs. Is it clear? Now I'm taking type 0 system. For type 0 system, ka will be what? It will be 0 and ess will be infinity. And when we talk about the type 1 system, again ka will be 0 and ess will be infinity. For type 2 system, ka will be constant we will have, and ess will be 1 by ka, that will be constant. So hence in type 2 system, when the input is unit parabola, the input is unit parabolic signal, there will be a constant steady state error. If I talk about the, if I go for the type 3 system, what happens? Ka will be infinity, ess will be 0. What we can say here, in the system with in systems with type number 3 and above, for unit parabolic input, the value of ka is infinity, and so the steady state error is 0. So here we are having a tabular column for the values whatever got so far. So one table is for static error constant, so for various type number systems. So here we are having error constants, that is kp, kv and ka. Positional error constant, velocity error constant, and acceleration error constant, and type number for 0 type, for type 0, type 1, type 2, type 3. Already we have discussed. For type 0, what will be kp? What will be kp for type 0? Just we look at here. One second. It will be constant. It type 0, the kp will be constant, right? and steady state error will be 0. Yeah, it will be constant. Is it clear? And this steady state error for various types of inputs. Input is unit step we have taken, unit ramp we have taken, and unit parabolic you have taken. And type number, type 0, type 1, type 2, type 3. For type 0, for unit step input, what will be the steady state error? 1 by 1 plus kp. Is it clear? Whatever we have discussed, that we have that arranged in a, that here it is got arranged in a tabular column. Just everyone go through this tabular column once. You're supposed to remember this tabular column. It is very important. Directly for solving the problems, this tabular columns whatever here we have discussed so far is much needed. So please everyone, you supposed to remember this one. So from the type 1 and above, what will be the kp will be infinity. Is it clear? See here, for type 0 it is a constant steady state error, and above this type 1, what will be this kp will be infinity. Type 1, type 2, whatever you will take this kp will be infinity you will have. Similarly for kv, for type 0 kv will be what? It will be 0. For type 1 it will be constant, and after that one, when we talk about this type 2, type 3, it will be infinity. Similarly ka for type 0 and type 1 it will be 0, and for type 2 it will be constant, and type 3 it will be infinity, and from so on it will be infinity only. Similarly for steady state error for various types of inputs. So this we have discussed. This is also what we have discussed in the just now in the discussion. For types type number of system, if type 1 system you take unit step input for unit step input it will be 1 plus 1 by 1 plus kp, and rest it will be 0. If we talk about the unit ramp, for type number 0 it will be infinity, type 1 it will be 1 by 1 plus 1 by kv, and rest it will be 0 0. Unit parabolic, for type 0 it will be 0, for type 1 system it will be type 0 system it will be infinity, type 1 system it will be infinity, and for the type 2 system it will be 1 by ka, and rest it will be, if we talk about type 3 system it will be 0. Just please everyone go through this, go through this one, go through this tables once. It is very important. Any doubt you can ask me. Are you listening? Any doubts you can text me or you can ask me. If you find any doubt, just unmute yourself and please ask me. I will here to explain you for a number of times. If you find any difficulty in understanding or you are having any doubt, please ask me. Is it clear? Please, people just feel free to ask me doubts. So about this generalized error constant coefficient we'll discuss later, and we'll have some problems on this particular topic what we have discussed so far. Yeah. Okay, this is the problem we'll discuss now. So for a unity feedback control system, the open loop transfer function is given. So for a unity feedback control system, the open loop transfer function is given, that is g of s equals to 10 into s plus 2 by s square into s plus 1. So we supposed to find the positional velocity and acceleration error constant. We supposed to find out what? We supposed to find out the positional error constant, velocity error constant, and acceleration error constant. And next in the b bit, we supposed to find the steady state error when the input is r of s, where r of s is given, that 3 by s minus 2 by s square plus 1 by 3 into s cube. So this is the thing what we are having. So just I will give some time for you. Please find out this positional velocity and error acceleration error constants. How you will find out? This is the data what we're having. Just you people find out the positional velocity and acceleration error constants. Yeah, please, any one of you, what is this positional error constant now? What is the answer for the positional error constant? Partho, tell me the answer. Are you there, Mr. Partho? What is the answer? And what is the answer you got? And other students, one second, I just forgot some of the names. Hmm. Partho Sarkar, fine, okay. What about this Rohit Verma? What is the answer? Are you there, Mr. Rohit? Rohit, reply to me. And Raghu Vamshi. Rohit, reply to me. Are you there? If you not reply means I will just remove you from the meeting. Are you there or not? What is the answer? What is the answer for this positional error constant? Fine. And what about this Raghu Vamshi?
Yes, sir.
What is the answer?
Infinity, sir.
Yeah, fine. Are you understanding right what I am saying?
Yes.
Fine, no problem. So when we talk about this static error constants for unity feedback system here given, so they mentioned that the feedback is unity feedback. So h of s is one we supposed to consider. So positional error constant kp equals to what we are having, limit s tends to 0 g of s into h of s. So h of s is 1 we are having, so limit s tends to 0 into limit s tends to 0 g of s, right? G of s they have given here, so it will be infinity, and velocity error constant will be infinity, and acceleration error constant how much? It will be 20. Is it clear? I hope that everyone got these answers. Is it or no? Yes or no? Do everyone got the answers right? Dheeraj, are you there? Mr. Dheeraj, Dheeraj, there? Okay, fine. So fine. Now that first job is completed. First job we supposed to find out the error constant that we got completed. Next job, what we need to do we supposed to find out the steady state error, and they have given the input. This is the input what we are having. R of s is nothing but 3 by s minus 2 by s square plus 1 by 3 into x cube. So this is the input what we're having. So now how come we can find out the steady state error? The steady state error for the non-standard input. So whatever the input here we are having, it is not non-standard input what we are having is obtained by generalized error series. So this generalized error series we have not discussed. So after the discussion of this generalized error signal series, we'll focus on this one. Is it clear? This topic I have not discussed to you. Later we'll discuss this question. Okay. In the next class, after the completion of this generalized error series, we'll come back to this particular problem. For now, we'll don't discuss that. We'll go to the next topic. next problem will go. Or else this can be done in another method. See here, not with that, we will just to work with this problem with one more method. Now we know the error signal in S domain. Is it clear? This is the error signal what we are having in S domain. Now this is a given signal. R of S is a given input what we are having. Is it clear? This is the given input what we are having. Now this is the G of S, loop transfer function, and this is the unity feedback. Now E of S is nothing but the just I am substituting the values over here in this. So after that one, by doing the simple analysis, mathematical analysis, now what we need to find out, I need to find out the steady state error that can be obtained by what, this final value theorem what we are having. So what the final value theorem states, is it clear? What will be from that final value theorem, what will be this steady state error? ESS equals to limit t tends to infinity E of t, that is nothing but S into limit S tends to 0, S into E of S. Just substitute here S into the value of E of S, what you got, this one. So finally what I am getting here is these terms will be 0 minus this will be 0 plus 1 by 60. So finally ESS will be, the steady state error will be what, 1 by 60 is the steady state error. That is the one method we can do, and another method also there, we can follow this method also. So like that we are having different methods to get the solution for this particular problem what we are having. So particularly whatever this generalized error series are there, the topic I will discuss later, and we'll focus on this in the next coming class. Okay, fine. Now when we move to the next problem, yeah, we'll going to this next problem here. Yeah, we'll continue in the afternoon session. I will stop here. Afternoon also our class is there from 3:30 onwards. We'll continue in the afternoon session. I will stop here. Please Dheeraj, please note the attendance, take the screenshots. We'll collect you later from your side. Yeah, thank you everyone. We'll continue in the afternoon session. 3:30 the session will start. In that session we'll continue. Until then, please go through the topic, whatever go through the topics whatever so far we have discussed in the morning session. If any doubts, please ask me. Okay, I will clarify that. For now I will stop here. Thank you all. In the next class we will discuss. చెప్పబ్బా ధీరజ్, చెప్పు ధీరజ్. తీసుకున్నావు ధీరజ్? ఓకే ఓకే, నాకు పంపిస్తే సరిపోతుంది. ఎప్పటి నుంచి ఉన్నాయి మిడ్ ఎగ్జామ్స్? అదే ఎంతవరకు అయిందో అంతవరకు ఉంటుంది మిడ్ ఎగ్జామ్. ఓకేనా? మిడ్ ఎగ్జామ్ వరకు ఎంతవరకు పోస్ట్ అవుతుందో అంతవరకు ఉంటుంది మిడ్ ఎగ్జామ్స్. ఓకేనా? సరే ధీరజ్, ఓకే ఉంటా. మరి పంపి నాకు అవి అటెండెన్స్ అవన్నీ. ఓకేనా? ఓకే అమ్మా, రైట్. చెప్పమ్మా.
సార్ మీకు 29th మండే
మధ్యాహ్నం ఉంది.
మధ్యాహ్నం ఉంది కదా, మార్నింగ్ అయితే ఏం లేదు సార్?
మార్నింగ్ లేదు
మీకు అంటే అక్కడ ఎంటెక్ వరకు సార్, ఈసీ వరకు ఏం లేదు?
ఈసీ వరకు క్లాస్ ఉంది.
ఎప్పుడు సార్?
పొద్దున్న ఉంటుంది మనకు. పొద్దున ఎప్పుడు అంటే 10 నుంచి ఉంది.
అదే ఇన్ఫార్మ్ చేయండి. అది ఆర్గనైజేషన్ కోసం ఇది. ఇంకెప్పుడు మండే ఎప్పుడు ఉంది సార్ క్లాస్?
మండే 10:30కి ఉంది. నాది కాదు, ఈయనది. ఎవరిది అంటే మన సివిల్ సిఎస్సి డిపార్ట్మెంట్ అవుతుంది, జావా అది. ఆయన చెప్పా అన్నాడు, అది ఉంది.
లేదు సార్, 10:30.
11:30 ఉంటుంది.
11:30 to 12:30 సార్? ఇంటెక్ సార్?
లేదు, సిఎస్సి సెకండ్ ఇయర్ వాళ్ళు.
మీరు ఈసీ
ఈసీ ఇక్కడే మనకు సంబంధం.
ఇది నా ట్యూస్డే సార్.
ట్యూస్డే మధ్యాహ్నం ఏం లేదు, ఫ్రీ. నాకు సెషన్ ఉంది ట్యూస్డే, వేసారు.
అదే మధ్యాహ్నం 11:15 to 12:40.
ఏమి
ఇది చేంజ్ చేశారు మళ్ళీ అందుకే.
పొద్దున్న ఉందా సెషన్?
పొద్దున ఒకటి ఉంది, మళ్ళీ ఇక్కడ కూడా ఉంది, రెండు ప్లేస్లో ఉంది.
ట్యూస్డే కదా?
ట్యూస్డే రోజు.
మళ్ళీ ఏం చేంజ్ చేసారు మా సెషన్?
అది కిరణ్ సార్ ఇచ్చింది లిస్ట్ ఆఫ్ నాలుగు.
ఏం చేయాలి మేము?
ఏం లింక్ పెట్టేసి చూసుకోవాలి.
అయితే నా క్లాస్ నేను వేరే ఆయన చెప్తాను, కట్ చేసాను నాకు ఆయన క్లాస్ ఉంది.
ఇదే
ఆయన ఏంటంటే కొంచెం బయటకు వెళ్తున్నాను తీసుకోమనండి చెప్తా. ఆల్రెడీ వేసారు కదా అది.